Right guys, in this video we're going to use trigonometry on right angle triangles to work out some missing lengths. So the first thing you have to be aware of is with this particular type of thing, so trigonometry, it only works with right angle triangles. Okay, so any other triangle, it doesn't work. We can only use this with right angle triangles. We also need to be able to label the sides of the triangle. So the first one that's really easy to spot is called the hypotenuse. It's always the longest side and it's also opposite the right angle. Okay, so whenever you have a right angle triangle and you're using trigonometry, label the hypotenuse. The other two lengths depend on where the angle is. So theta is the symbol we give to an angle, and in this particular case it's here. So the other two sides are called the opposite and the adjacent, and it depends on where this angle is. The opposite side, as you've probably guessed, is opposite the angle. So this side here is the opposite. Now this side here is therefore called the adjacent. Okay, it's called the adjacent. Easy way to remember it is opposite is obviously opposite the angle. The adjacent is always in between the angle and the right angle. It's always in between them. Okay, so in this particular example over here, the angle is moved, the angle is over here, in which case the opposite side is this one, and the adjacent side, so one next to the angle, remember adjacent means next to, so next to the angle, but it's also the one that's in between the right angle and this particular angle that we've been given here, theta. Okay, so this one here is the adjacent. Okay, for the sake of what's going on for the rest of this video, the hypotenuse I'll say H, the opposite I'll say O, and the adjacent I'll say A. But that's what it means. Okay, whenever you have a right angle triangle, you need to label the sides. So let's get cracking with a question. So here is a right angle triangle, and here's my angle. I've been given this side and I want to work out what this side is. So the first thing to do is label the sides that you've been given. Well, I've been given this side, so it's the hypotenuse because it's opposite the right angle. So I've been given the hypotenuse, H, and this side here is the one I want to work out, and it's opposite this angle here. So I've been given the opposite side. And with trigonometry, you have to remember SOHCAHTOA. Okay, there's lots of different teachers have lots of different ways of remembering this. It's entirely up to you. They might have their own way. As long as you remember SOHCAHTOA, you're in business. Why is that important? Well, because we've been given the opposite and the hypotenuse, it tells us we're using this one because it's got the opposite and the hypotenuse in there. Why does that help you? Well, once you've figured out which one you're using, you can then draw your little triangle here. And you might have seen this using distance, time, and stuff like that. And we have sine theta, and then because it's opposite in the middle, I have opposite, and then it's the hypotenuse there. Okay, and I'm going to use this triangle to work out this missing length. Now I want the opposite, so I want the opposite. So what does that equal? Well, we cover up the opposite like so, and if you remember how this triangle works, sine theta, remember theta just means the angle, times by the hypotenuse. Okay, so what we do once we've figured out what we're doing is substitute in the values. So theta is the angle, so the angle is 35 and the hypotenuse is 7. Okay, so what you do is you grab yourself a calculator and we simply just type that in. So sine is this button here. Now notice it comes up with a bracket, so just be careful that when you put your 35 in, which is your angle, you actually close that bracket, otherwise you will get the wrong answer, times by 7, and we get a big number, so 4.0150, etc, etc. The question will probably tell you to round it to one decimal place or a whole number or whatever, in which case you just round it to what you need to round it to. So that's one example. Let's have a look at another one. So again, right angle triangle. This time I've been given this side and I want to work out this side. So label it up. Well, there's the angle that I've been given. So this side is the opposite. This side is the hypotenuse because it's opposite the right angle and it's obviously the longest, which means this one here must be the adjacent. Again, go back to your SOHCAHTOA. If you've got the adjacent and the opposite, which one is it? It's this one here, because you've got the opposite and the adjacent. So draw yourself your triangle, and tan, theta, opposite, and then the adjacent, so TOA. Now I want to work out the adjacent. So what do I need to do? Let's have a look. If I cover up the adjacent, I'm doing the opposite divided by tan theta. So opposite divided by tan theta. So substitute in what we know. Well, we don't obviously know the adjacent, but we know the opposite is 8. Divide by tan, and the angle is 17, so I divide by 17. And again, we get our calculator out, and we say, okay, 8 divided by, this time it's tan, so that one there, tan, and the angle was 17. Again, don't forget to close the bracket if your calculator does that, otherwise you're going to get an error. And we have 26.166, and so on and so forth. Okay, so remember, you might just need to round that depending on whatever the question says. Okay. And finally, the last one here, again, a right angle. I've been given this length. I want to know what this one is. It's the value x. Label them up. That's the hypotenuse, longest side, and opposite the right angle. This one here, well, there's the angle. So this is the opposite side, so I don't care about that. This is the adjacent. It's between the two angles. So adjacent and hypotenuse is your K. So again, draw yourself a little triangle to help you realise what to do. So cos theta, adjacent, and the hypotenuse. This time I want the adjacent, so I cover up the adjacent. I'm doing cos theta times by hypotenuse. Substitute in what we know. Well, cos and theta this time was 26 times by the hypotenuse, which was 8. So put that into your calculator. So I bring my calculator back here. Cos 26, don't forget to close the bracket, times by 8, and I get 7.190, etc., etc. And again, you can round it to whatever the question says you need to round it to. So hopefully that helps, guys, and I'll be doing the missing angles one in a sec.